Hey everyone, welcome to today's Explainer. I'm going to be your guide today, and as a professional Azure SQL database expert, my one and only goal right now is to give you a crystal clear, step-by-step overview before you dive into your upcoming hands-on lab. We're going to be tackling one of the absolute most critical skills any database administrator can have in their toolkit, backing up a database directly to a URL in Azure, and then pulling off a high-stakes data rescue. We've got a ton of ground to cover before you even touch a keyboard, so let's jump right in.
Okay, here's our flight path. We'll examine the anatomy of a disaster, get the local environment prepped, configure our secure Azure storage, execute the actual backup, run a simulated rescue mission, and then finally, clean up our resources like true professionals.
First up, the anatomy of a disaster, because we really need to establish the exact worst-case scenario that makes this entire lab so essential for your day-to-day work.
I want you to picture this. Just imagine the sheer heart-stopping panic for a second. You're working in SQL Server Management Studio. You write out an update statement, you highlight the text, and you confidently hit execute. And literally a split second later, your stomach completely drops. You realized you forgot the where clause. You didn't just update one customer's record, you just overwrote millions of rows in a live production table. Your pulse is spiking, your phone is definitely about to start ringing. What's your very next move?
Now, as database pros, we spend a massive amount of time prepping for hardware failures, right? We're talking redundant disks, failover clusters, regional outages, the whole shebang. But honestly, human error is almost always the most common and destructive reason we actually end up needing our backups. An unintentional mistake from an admin or developer requires an immediate, point-in-time data restoration to literally save the business. You can't exactly just reboot a server to fix a dropped table, you know? You absolutely need a rock-solid backup and recovery strategy.
So here is a 30,000-foot view of the exact sequence of technical steps you'll be executing in the lab today. We aren't just talking theory here. We're actually going to build out the architecture, intentionally break the data, and then swoop in and fix it using the cloud.
Moving on to preparing the environment, let's talk about getting your local machine or lab VM completely ready to go.
Before we can even think about going up to the cloud, we absolutely need our local baseline. In your lab, you'll start by opening Visual Studio Code and cloning the Microsoft Learning DP-300 repository right to your C drive into a folder called Lab Files. Once you've got those files locked in locally, you'll jump over to SSMS. You'll connect to your default instance and run the provided T-SQL script to restore the classic AdventureWorks 2017 database. And just like that, we have our pristine starting state database to use as our proving ground.
All right, Section 3, configuring Azure storage. Local database is fully restored, so now we shift over to the cloud infrastructure side to build our secure vault.
Instead of clicking around the Azure portal all day, we're going straight to the Azure CLI right inside the VS Code integrated terminal. You'll run as login to authenticate, and then you'll create a highly specific resource group and storage account. And pay really close attention here. You must use globally unique names for your storage account in Azure. It has to be between 3 and 24 characters, numbers and lowercase letters only. You'll basically append some random characters to the names provided in the lab to make sure nobody else in the world is using them. Once that's spun up, you'll query your storage account keys because you're definitely going to need key 1 for the next step.
Now, before we look at the SQL code itself, we have to talk about SAS tokens. A shared access signature is strictly required to securely bridge our SQL server to Azure Blob Storage. We literally never want to hard-code our primary storage account keys directly into SQL Server. Never. Instead, we use the CLI to generate a SAS token specifically for our backups container. Think of a SAS token kind of like a digital VIP hotel keycard. It grants access to one specific room for a specific amount of time, and then it completely self-destructs and becomes useless. It delegates restricted access like read, write, and list permissions, creating a temporary, super secure bridge.
So what do we do with it? We take that freshly generated SAS token and wrap it into a secure credential directly inside SQL Server. Back in SSMS, you'll execute a create credential statement. The name of the credential has to match your Azure Blob container URL exactly, and the secret is just that SAS token value you just made. By doing this, SQL Server now inherently knows exactly how to talk to your Azure storage container securely without ever prompting you for authentication again. Section 4. Executing the backup. We built the vault, we secured the keys, now it's go time. Let's send this data to the cloud. Notice the very specific transact SQL syntax you'll be using here. We aren't backing up to some local C drive, we're issuing the command backup database to URL.
You just point it to the full HTTPS path of your blob container and specify your .bake file name. Once you fire that off in SSMS, the data just streams right up to Azure. But hey, as database experts, we always verify. You'll jump back to your CLI and run as storage blob list to validate that the file actually landed in the container. Trust for sure, but always verify.
Section 5. The Rescue Mission. Our safety net is securely in place, which means we get to trigger the inciting incident and launch our rescue mission.
In the lab, you're going to actively simulate that total nightmare scenario we talked about earlier. You'll open a new query window and run a massive update statement against the person.address table. You are going to change a specific customer's valid address to the literal string, "This is a human error." You are intentionally breaking the data. Just please don't try this at home on your actual production servers, okay?
The damage caused by a sloppy query like this is pretty much catastrophic. The original, valid address data, just gone, completely overwritten. If this were a production database, any application relying on this data is currently broken. We need to revert this immediately, using the cloud backup we just pushed. Now here is the absolute magic trick, handling active connections. You obviously can't overwrite a database while applications are actively querying it. So you'll use a command that acts like a digital bouncer, forcefully kicking out active connections and rolling back any half-finished transactions. You'll run alter database set single user with rollback immediate. Boom, database locked down. Then you apply the ultimate fix, restore database from URL, pointing right back to your Azure Blob. Finally, you just flip the database back to multi-user so the apps can connect again.
Whew! You can breathe a sigh of relief now, but your job isn't quite done. You must always verify the rescue. You'll run a quick select statement against that person.address table to make sure the customer's real address is back. And let me tell you, seeing that original data pop back up in your results grid, that is literally one of the best feelings you can have as a DBA. Which brings us to Section 6, Clean up resources. A true professional always cleans up their workspace when the job is done. We've got a pretty strict cleanup checklist. In the cloud, leaving resources running literally just burns money. So if you created a dedicated resource group for this, head into the Azure portal and wipe out the entire group. If you're sharing a group, meticulously delete only the storage account you provisioned. Locally, you'll delete the c/lab files directory to get your disk space back. And finally, drop the lab database from your local SQL instance.
Pro tip for when you go to drop that AdventureWorks database in SSMS Object Explorer. Right-click, select Delete, but you absolutely have to check the box at the bottom that says Close Existing Connections. If you don't check it, SSMS will probably hang and throw a nasty error because some background process is holding on to the files. Check the box, hit OK, and your environment is completely clean.
All right, you are now officially prepared to tackle this hands-on lab. You know exactly how to leverage Azure Blob Storage, generate secure SaaS credentials, and execute a flawless point-in-time restore right from the cloud. But I want to leave you with a question as you move over to your keyboards. You know how to save the data in the lab today, but are your real-world enterprise production databases actually this secure? Take the skills you practiced today out of the lab, look at your own architecture, and make absolutely sure your business is protected against the inevitable human error. Have fun with the lab, everyone.
Hey everyone, welcome to my channel. In this section of lab, we'll go through DP-300 database administrator, Azure Labs, and we are going to do the very last lab, which is backup to URL and restore from URL. So we'll take a backup, keep that into URL storage, and then we'll use that like below storage, and then use that backup from the URL storage to restore. Think that as a database administrator, that is very important, your kind of day-to-day task, just to make sure that there's a proper backup in place and you can restore if something happened to your database. And there are many ways up to do restore. This is one of them into cloud environment. This is like you can think if you use AWS, that is S3 storage. So I'll share this GitHub link into description section so that you can follow or when you do practice in your own environment. So another thing to be noted that you downloaded all the required files beforehand because those are needed when you go through. So and here, let me connect to the that SQL Server Management Studio. And when that open, you can see that connect to the server. So here you have to pass your server type, server name. Also, if you want, you can go to like connect to the specific database. So, and there can be authentication that you set up for your database level. So you can set that up. Then select the trust server certificate in my case, and then click connect. And after that, select that databases and then click on new query. So we're going to restore a database now first based on backup. So let me copy the code for that one. So restore database, database name, and from this, that is my backup. And it will create two files. You can see that MDF is data files, all the data files path, and then log files. So let me execute that one. And you can see that query executed successfully. And if you refresh that, you can see that database here. So now configure backup to URL. So for that, let me go to the script. I can do that from straight like to the path itself so that I do not need to type so many things here. So here you can see that I can go here and do that one so that I do not need to go path this path. Others I can go also from like here all files I can go to terminal session. So open in Windows terminal. Now type the command connect to it using ID password, your Azure portal login password. I'm logging into the portal. So now go to resource group. You can see that resource group is there. So you need to create resource group when you do into your own environment. And if you go to storage account, you can see that no storage account to display. So let me create a storage account here. Let me type okay. So this is the syntax. Let me first modify all the codes, then I'll go through this one. So we can see that resource group is created already. So now we're going to create a storage account. So storage account name, resource group name, and then storage version 2, and this the region or location. So let me execute that one. So storage account is created. So we are going to create a storage account. So storage account name, then the group, then type is storage version 2, and the region. Copy that command, go to that PowerShell window and press enter. So you can see that storage account has been created. Let me go here and refresh. Okay, I type here storage account. We can see storage account West US under this subscription. Kind is version 2 has been created. We can see that one from here. Now, next we will get the keys for this storage account, which we are going to use later steps. So here you can see that is storage account keys, and giving that group, and also the name. So let me copy that command and paste it here. Execute the command. So you can see that key is created. Let me go there, portal, and see that one. So if we go to that storage account and go to that security plus networking, and if you go to access key, you can see that two keys are there. So it is created now. Next, we are going to backing up database. So for that, the command is container, giving backup name, giving account name, then account key that we created before here. That is storage key. What is the key name? Key list, storage account key is storage key. So we have to get the keys now. So is this storage account, and you can see the key. You can copy it from here. Copy, and then paste that here. Now copy that command. Execute. Press enter. So here we can see that it created a container, storage container backup. So if you go there and storage browser, go to Elop containers, see that there's a container backup is created. Next, we are going to execute. This key I need to copy again. Let We can also see by using this command that container um, is created, backup container. So you can see that one. Now next we are going to we are going to generate a shared access signature for the container level. If I go to portal now, so you can create a SAS. Here is that shared access signatures. So we're going to all this code now. You can see that create and generate. So generate and execute that one. Invalid date time. So I have to modify the date. Okay, because that is old one. So let me update that code. So now I'm going to create a now I'm going to create a shared access signature at the container level. So let me execute the command. So it's created a shared level access signature. So take a copy of this signature and put into Notepad. Now let's create a credential. So connect to the Microsoft or SQL Server Management Studio. And here, after authentication, let's open a new query window and paste the T-SQL. Let me copy from here. So we need that shared access signature. Then we also need the secret. Now execute that one. So it's completed successfully. So we can see that it's actually select this credential, create credential with this identity secret is this one. So commands completed successfully. So it's created a signature here. So here we created a credential that will be used for later session. So if after this, let's go to the security and you can see that credential here. For any reason, if you need to recreate, you can just drop and then you can create the credential. So now let's back up database to URL. Open a new window. And execute that one. So cannot open backup device. So just to make sure that this name is correct, let me find that one. So I was getting some issues. So what I have done, I have dropped that credential and then create a credential, use that SAS token, and then I am executing backup database. So backup currently is running. So you can see that successfully processed. So let me go to the portal and see that one. That stress browser. We go to build ops container and we create that backups. And here we can see that database backup. So that means backup completed successfully. We can let me check with that PowerShell command. So you can also see that backup information here. So validating backup. Now let's do restore. So for that, let me go back to Management Studio, open a new query window and execute the below SQL or T-SQL. So you can get this information that when that is modified. Now, what we are going to do, we are just changing something. Consider that we are just manipulating this data. Let me open a new query window and run some update command. So we are updating and there's a human error for our testing purpose. So select that, execute that one. It's executed, and if you go back, you can see that address line has been changed now. So now we need to restore this database. So to restore this database, to get it back with with the correct informations, let me open a new query window, copy the syntax. So here you can see, okay, let me from that URL get the URL. I've got. So what we are doing here, you can see that we are using set single user with rollback immediate syntax. What it does, like that open transaction, that there are some transactions, so someone is connected already there, so that will be rolled back. And if there are some active, normally there can be some active connections and that can hang there or waiting there. So this is just to roll back those session transactions. So let me execute that one. So that restore database in progress now. You can see that restore database successfully processed. So let me go back those commands. So let me execute now again to see that address is fixed. And we can see that it's completed successfully. So we have successfully completed this lab. And it also conclude all the labs for Azure SQL Database Administrator lab section. If you have any questions, please add that into comment sections. Otherwise, see you into another labs. I have placed many other Azure labs which you can go through. Thank you.